Geometry Common Core, Regents Review, video number 5. The area of a sector. This is definitely a high priority topic, as all the topics are in these videos. That's why we're making these Regents Review videos on these specific topics. They show up on pretty much every test. Area of a sector is a big one. You're going to see this maybe once to even twice on an exam. Sometimes you see arc length. That's not as common as area of a sector, but you should know that one as well. Now, they give you on your reference sheet the area formula for a circle. The area is pi r squared. But when we're talking about a sector of an area of a sector, we're not talking about the area of the whole circle. We're talking about the area of a piece of a circle. So we have to modify it a little bit to be area equals x over 360 times pi r squared. And really what that does is the x over 360 is saying what portion or what piece of the circle, like how much out of the 360 do we want the area of. So, if we're doing half the circle, meaning half the area, or a quarter of the circle, that kind of thing. So we need to know how much of the 360, how much of the circle, and it's that portion of the area. Now, this particular question says the area of a sector with a radius measuring 15 is 75 pi centimeters squared. What is the measure of the central angle? So here they're actually giving us the area and want us to do the formula kind of backwards to solve for the x that would go over the 360. So we set it up exactly what we know. We know the area is 75 pi. And we set that equal to the x over 360. Pi and r squared is going to be 15 squared. Now, one of the things you should always do, if you ever find an equation that has pi on both sides, just immediately cross it out. Basically, it's like dividing pi on both sides. You don't need it, and it just makes things more complicated. So get rid of that. We could also simplify 15 squared. And so what do we get when we do that? We get 75 equals x over 360, and 15 squared is 225. And so now it's just, get x alone. We have to remember that these are being multiplied. And anytime we try to get x alone in an equation, we're getting the other things to the other side. We're doing the inverse operation. So the way I could get rid of this times 225 is by dividing 225, because it's the inverse operation to the other side. And x over 360 is really dividing by 360. So the opposite of that is going to be multiplying by 360. You could also kind of think of it as times the reciprocal. Sometimes people like that. And so I could type this into my calculator. We have 360 times 75 divided by 225. Oh, missed a 2 there. And the result is 120. So x equals 120. And that's our answer. And of course, you could kind of guess and check these because it's multiple choice, like 120 over 360 pi r squared. Does it come out to be 75 pi? But if this, say, were a part 2 and you didn't have these choices, that's how you're going to have to do it. The next topic in the diagram below, a right triangle with an altitude. This particular topic is what we refer to as a geometric mean. And you had 2 formulas that stemmed from this. Basically, what's happening is when you have a right triangle with an altitude, it makes a right triangle here and a right triangle here, and they're all similar. And you get a lot of, with similar triangles, we get a lot of proportionate sides, and with proportionate sides we can create proportions. Well, from those proportions comes 2 formulas that, if you remember these, it's very helpful. The first one is that the altitude squared equals part times part, and what that refers to is, here's the altitude, so that length squared is the 2 parts, the product of the 2 parts down here. Like if I were to just put some hypothetical numbers in here, like 4, 2, and 8, because 4 squared is 16, 2 times 8 is 16. So the altitude squared is the product of the 2 parts. And the other formula that we get from this topic is that the leg squared is the part times the whole. These are legs here and here. So you actually get this formula in 2 versions. First, I'll do this one. So that squared is this part times the whole thing. So again, if we wanted to throw numbers in here to make sense out of it, it would be saying like, all right, 4 squared is 2 times the whole thing is 8. The leg squared, the part attached to it, because they're attached here, times the whole thing. It would be the same thing on the other side, that this leg squared is this part attached to it times the whole thing. So those are your geometric mean shortcut formulas. Let's see what this question is talking about here. So what do they give us? KG is 9, IG is 12, and they want ultimately IM. But anytime they give you the altitude, you got to be thinking about this formula. Altitude squared is part times part. So they're setting me up actually to find this first, which is good because to find this leg, I need the part attached to it and the whole thing. So this is kind of a two-step question. You first have to find this piece with the altitude squared, and then we use the leg squared formula to find the missing part there. So first let me do the altitude squared one. So altitude squared is 12 squared equals the part times the part. That's 144 equals 9x. Divide the 9, and 144 divided by 9 we see is 16. And so now we know that this is really 16, which would mean the whole thing, 9 plus 16, is 25. And now we can do the leg squared piece, x2 squared equals the part attached to it times the whole thing. And so we end up with x squared equals 16 times 25. And so I already have 16 typed in there, so times 25 is 400. And I'm going to have to do the square root of that number to get a final answer of 20. And that's ultimately what they wanted there. Okay, one more topic in this video to cover. What is the equation of the image of the line y equals 3/2 x minus 4 after a dilation of a scale factor 3/4 centered at the origin? So this is what we refer to as a linear dilation question, and there's really two common versions of this. Now, no matter what, when a line is dilated, the most important fact is that they have the same slope, because when lines are dilated, they produce parallel lines. So right away, if I see the slope of this line is 3/2, let me zoom in a little bit so you can see that. The slope of this line is 3/2. I could get rid of that. I could get rid of that because I'm looking for something that has the same slope. Those have the same slope. Now, the only real question on a problem like this is it the same slope and the same y-intercept, or is it the same slope and a different y-intercept? And the rule for this, and I'll explain why this happens on this exam, but the rule for this is anytime they mention it's centered from the origin, you're going to have a different y-intercept. Anytime it's mentioned from a point that's not the origin, like if they say centered at the point 3,4 or 2,7 or -8,5, you end up with the same exact y-intercept. Now this one says origin, so it's not the same y-intercept because our y-intercept here is -4. So here's my answer. Now let me talk a little bit about why that is the case. Now why is it -3? Well, what happens is you get the same slope, but you multiply the scale factor by the y-intercept. And if you take your y-intercept of -4 and multiply it by the scale factor, that's how you get the -3. And that's what we see here. Now, how come when it's a point that's not the origin, it's the same y-intercept? Well, because what happens, at least in the past, every time they give you a point that's not the origin, they give you a point that's actually on the line itself. Like in this case, let's say they gave us the points, 2, -1. If they said centered at the point -2, -1, well, this is a point on this line. Like if I plug in a 2, I get a -1. And when you dilate a line from a point on the line, it just continues out on that same line. So really just try to remember the rule that no matter what, it's the same slope. And if it says origin, it's a different y-intercept. You multiply the y-intercept by the scale factor. But if it's not the origin, then it's the same exact linear equation. All right, that's it for Regents Review Video 5. Good luck on the test.